things. And here, the very bad outcomes, there was like a bad initial description. What we meant is how to prevent field shutdown and technology delays or limitations, though we did generate a whole slew of concerns as well. So first, some kind of like broad definitions, what are field limiting bad outcomes? And so, there's a whole bunch of different kind of bad outcomes here, like banning specific technologies, halting the entire field. Whoa, sorry. It moved. Getting to like unfortunate private or national monopolies over it, surveillance control, and so on, like various different kinds of ways of preventing the advancement. Then we source some examples of this happening in other fields. So for example, nuclear power, there's like really good reasons why it's restricted, but it's just an example of a restricted field. Green tech was slowed down and not exactly banned, but slowed down massively in a bunch of places. And there are parts of green tech that are outright banned. Like we could actually solve a lot of the carbon fixing problem by doing a lot more bioengineering, but like, that's also dangerous in other ways. So gene therapies, notoriously banned. Nanotech got slowed down. Cryonics was slowed down and effectively kind of banned for a while, and so on. So these are a bunch of examples. Even cryptography was banned for a while. In fact, Foresight has a lot of people that fought that war for us and solved it. So there's a lot of examples here of this happening. Then we talked about a few of like different jurisdictions that, in the hope of creating some jurisdictional redundancy. There's of course like the U.S. where most of the neurotech work is happening. Also Australia, Netherlands, Canada, Switzerland. These are all kind of jurisdictions where a lot of neurotech R&D tends to happen. Prospera came up as a good example, like jurisdiction that could allow some of this to happen. There's a lot of kind of charter cities. Then, theoretically, potentially Mars eventually, although the timeline is rather short, and so on.
Leave now.
Yeah. Yeah. You unpack the lab and then you get AGI. Oh man. Then we talked about how to influence jurisdictions over time to make sure that like you get to good outcomes. We also sourced a bunch of examples that if you kind of scale the industry quickly, then the industry tends to fight for itself. Like for example, there's lots of good evidence for lots of fields persisting and kind of carving a space for themselves just by existing. So if you just do that really quickly, then the field sort of protects itself. Separately from jurisdictions, there's just the process of like, let's make sure that we don't kind of like run out of money in the entire industry. So let's get a bunch of governments and VC and philanthropy to allocate capital towards this. Generate more financial instruments to progress the R&D. Then most of the focus of went into ways of getting the mainstream environment to align. So this goes into kind of like propagating values, getting alignment on the messaging and communication, how to coordinate large groups, making sure that like doing good balancing of all of the communications that need to happen. Basically effectively good mimetic engineering. Then we talked about kind of like problem solving the negative. So like make sure, so it's not just about kind of like making the field succeed. We have to make sure that the field solves the negatives and make sure the problems and negative use cases are well addressed. Like there are lots of very big valid concerns. So let's make sure that those are addressed. Then, stress the positives. Deliver extremely good positive results early to build confidence so that it's not, if you get a field that like where like all the initial results are bad, then that's more likely that the field will get slowed down. Then we kind of like thought about some of what would potentially be interesting results. We talked about IP. We talked about all kinds of other, getting lots of communities in academia and broader industry to get more involved, and so on. You can see some of the questions here. There were also a few interesting notes around establishing self-modification as a human right. First off, like there's been a number of attempts at that in the past, establishing groups of humans that fight for their own rights. Then at that point, it's like, well, who are you to exclude them. Then we did list a whole bunch of concerns that need to get addressed. This is not at all exhaustive, and there's a lot more. And then some of the mechanisms that have happened in the past that lead to this kind of bad policy creation. Cool. Any questions? Yep.
What about intelligent? I mean, we might say, oh, she's a musical genius, he's a math genius. It's not a single-dimensional thing. I'm a little concerned about using it too broadly.
Yeah, I think we all agree. Yep.
Yeah, so there's I think there's a disconnect between people in this room and outside of this room, right? So,
Hi, camera.
But I mean, there are people that would fight you, for instance, about whether or not you want to help deaf people hear, blind people see, whatever. But most people probably...
And these are legit fights that are happening right now.
Right. So most people probably wouldn't, but there's that community. But then when you start to think about changing intelligence, interfacing with the brain, all that sort of stuff, the upside of it is compensating for damage and disease, right? Which again is probably less controversial outside of the room. The people that are pushing the field across not just this, but other communities are thinking about, how do I interface with my computer? How do I get super intelligence? How do I beat the AI? And which is just, maybe they're maybe they're correct and ahead of the world because the world hasn't seen what AI can do. And then everyone just catches up, or maybe they view that as apparent. And so I guess I'm curious if you have thoughts on how do you manage that fundamental conflict between the people that are pushing the field that would develop the compensatorial, the things to compensate for damage function, also have personal agendas and interests which are way ahead of the average person on the street.
I mean, and I wouldn't necessarily just directly describe way ahead or whatever. I think there's no spectrum here. In fact, there's a very large plural environment with lots of different opinions and perspectives, really massive space with huge disagreements in that space. And there's good, in the liberal democracies, there's good precedent for establishing rights for the self and for the individual, as long as you're not infringing on the rights of other parties. Where this gets, and so that, for example, is fine for self-modification, right? If one person wants to go get tattoos, that's allowed now, right? That wasn't necessarily allowed in all societies. In fact, in some societies, it's not. If somebody wants to go and get piercings, somebody wants to wear a certain type of clothing, we fought pretty hard to get protections for that. That will extend broadly to some of this. Now, where this gets messy, really messy, is with children. And you see a bunch of those fights happening right now, where there's all kinds of questions and fights around should you screen for certain genes in IVF, for example, or should you and that might be preventing specific diseases or damage, or it could be enhancements, right? And so that's where a lot of that discussion is happening. I think the timelines are such that the children issue is less relevant, and I think we'll likely encounter very high bandwidth BCIs and likely some early uploads before those fights about what do you do with children get fought and decided.
That's optimistic.
Yeah, I did give some spicy timelines at the beginning, so. But I will say that my track record timelines is not that off. All right.
There. What would you want people to do tomorrow to kind of get working on this?
Oh yeah, and sorry, I kind of dodged the question very elaborately there. In the I expressed my broad opinions about how the world should navigate these kinds of issues, but very concretely, I think the big way to address that is just broad mimetic diffusion, meaning the earlier part here about kind of propagating a lot of the values and propagating the reasoning and getting people to understand the why is super critical. That is absolutely essential to a bunch of this stuff. And so there are a lot of groups that are just forging ahead without doing that, but I do think that many of us, Foresight NPL, spend a very large fraction of our time diffusing the memes to everybody to help understand the case for these things.
When do we start the media company?
I think many have been started.
Oh, good. Never
Yeah. No, yeah, they exist now, which is pretty cool. But you know, like, in fact, the Marvel movies are extremely pro tech advancement.
True.
There's a lot of stuff there, like nanotech, cryo, BCI, lots of things. So
It's going to be a long time.
that was no accident, by the way. I don't think that was at all an accident.
The right mover.
So yeah, we can get bitten by radioactive spiders.
Yeah. Yeah. So, and you had a question about what should we do or something
Yeah,
like that?
yeah. But I guess you said it, like mimetic dispersion.
Yeah, mimetic diffusion. Yeah, and I think like this jurisdictional question I think is very important, and so I think establishing groups that kind of like help protect neurotech rights in a bunch of places seems pretty important. All right, thanks.
Awesome. Thank you. Yeah, I think we're almost. Well, we're nearing the end here now, especially battery life consulting. Okay, last but not least, final one, and then we do the closing. Biohybrids. Do you want to come up here?
The notes are actually
On the towards the bottom.
'cause my phone.
Here. Or
It's in one of the cell blocks. It's like
a different,
few rows above.
a few rows above. Okay.
It has
This one?
yeah, that one.
Okay.
These two can
Let me just move them. Is that okay?
Thank you. Yeah, I love that. Thanks.
So I'll move them to biohabits. Otherwise, we will get confused. And then we have.
Would you like to?
Sure.
Okay. Because our presenter, Max, is not here.
You will do a great job.
Okay.
Yes.
So these are
I'm
some
sure of it.
summary of the.
Microphone.
Go for it.
Okay, so these are some summary of the super fascinating discussion about the biohybrids. In our discussion, we chatted about this paper. It's called "When Bio Meets Technology: Biohybrid Neural Interfaces," and it's written by a researcher who's now working with Max, and it's basically talking about how we have all these electrodes and like these digital implants for BCIs, but what about electro implants, devices that can hold live cultured cells? So that's where Max's biohybrid neuroimplant direction is. So that is the research topic, and in terms of funding, like opportunities and challenges. So it would be really great to just jump in and solve problems for patients with eye issues. And there's like some subtopics that we mentioned. For example, like the colors. It's like vision is so refined. So like it's not so easy to just solve it, but color apparently is a component, but also the distractibility. So like the devices can provide vision sometimes in a way, but you were telling a story about the patient.
Yes, on the biohybrids, like the discussion was around a chip that I guess goes on the surface of your brain, and then neurons that project down into your brain, and they're heavily modified so that they stay alive and connect. And the discussion was like, well, what can you do with that, today? What are the applications? And it's an interesting thing because it's hard to interface with the brain with electrodes and that sort of thing. You've got something hard going into something squishy, so it solves that problem. But on the other side of it, you don't have full control over where they go. So what does that mean, and what are the kind of utility areas, and how do you do it? So that's we went down. I think that's being decided and figured out in real time. But we went down and talked about that a little bit. The vision stuff was more about optogenetics and just how you interface with the eye, which doesn't use those technologies. In some ways it's simpler because you can get at the eye directly. But then there are also the questions of like, what is vision, which go same questions hold, but more so if you're going directly in the brain, because like, are you interfacing with functional elements or more broadly with pieces of compute, and how does that all work? So that, I think that's I don't know if I missed anything.
Yeah,
but
no, that's great. And then also something about the fixation about the eyes. Sometimes when it's implanted for the vision for the patients, they don't see it like how we see it. It's sort of like they have to move around. So it depends on the patient's ability to fixate as well.
That was a previous technologies around electrical implants. Yeah, so there's the question of like for all of these things, right, which is being understood in real time of like what exactly are you connecting to? So for vision, right, vision is a very highly refined sense. So presumably if you're putting an implant, you want it to respect that for it to be useful. And if you do respect that, is it also like something that the patient is going to want to use? And so there was discussion about like what is required to do that, whether you need to be able to get, you know, full vision, or you need to be able to just respect geometries and things like that. And all of this is probably, you know, and we didn't talk about his technologies, but I would suspect that you answer these when you're in people. But same questions, you know, but harder go for the brain when you're, you know, if you have a very high density set of neurons going into the brain, then the question to be determined still, because it's ahead of our current understanding, is, you know, what do you get, right? And how do you use that?
And
You
another
want to say a few things about this part here?
Oh, the R&D.
Yeah.
Okay. So the challenges related to the R&D, Max shared a little bit, is the immune attacks, of course, and also the graft survival is also super critical, but that's also really hard. Another thing is it's hard to license certain tools because companies who have the tools and can license are so worried about if something goes wrong in the patient's experience. And if just one patient has some issues, then the FDA can come in and just shut down the whole pipeline of this, which they can, of course, start another device, but it'll take 2 years and millions of dollars. So companies are very careful about licensing, which is like a big challenge in the R&D process. Another thing about funding earlier is just, it would be really great to have a cool GPT-4 moment. Like something big for the the BCI field to really thrive. But there are also some plus that's really great for the field, like neurons are not dividing, so I guess there's less concerns for if you implant something and they just go crazy and divide and divide. The brain is also really good at finding meanings if you feed it information. So Max mentioned something about like patients were able to see some vision with the implants with the sound coupled. And when they shut off the vision with just the sound, there was that co-triggering. So something along those lines, but it just shows that the brain is very flexible in building that connections. So lots of hopes in the R&D space as well. And then the last thing is that with electrodes, it does take up space with the wiring, but with cells, and then brain has so little space. So with something that takes up space in the cell with traditional electrodes versus something that's more cell-based, there's also unique advantages.
Cool.
Yeah, no, there was some discussion around the different ways of getting information in and out of the brain, right? And we talked about optogenetics, which is light, electrodes, and neurons coupled to electrodes. And the short answer is there's no silver bullet, but the neurons coupled with electrodes seem to have certain benefits in terms of longevity of an interface.
Great. Thank you, guys.
Thank you.
I think we have time for like maybe one question or comment.
Your shirt is a little biohybrid.
What's that?
It's
On brand.
bio and machine.
Any other questions, comments? I have one, like, what's the number one thing that you'd incentivize folks to do tomorrow to get more work going on this area?
I would say thinking about, I guess just what we discussed about the media and the Marvel we discussed about the media, like the Marvel movie, and it got me thinking, because Max was also mentioning, we need like a GPT-4, like a big sensational moment for BCI. Well, he was talking about how, Elon can go as long as he wants to like build the BCIs, but for the field to survive as a whole, we need something that's sensational, like a big splash. So I would say something we can do right away is to just like tap into our imagination and think about what kind of those things could be, and kind of build some cultural narratives around it to get people excited, or just like be more concrete about what can be achieved.
Great. Okay, final question over there.
On the tool licensing issue, is it that they're tracking it on the IP level or at the company level?
So what happens is like all of this stuff is very highly fragmented. You need a viral vector, you need promoters, you need an effector molecule, et cetera, right? And so invariably you are in licensing from other people, and those people that are out licensing are out licensing to multiple people, including large pharma. And like large pharma's nightmare is, I may or may not use this thing, right? I license it because I think it could be cool, and then some small company does something crazy and a patient dies or gets super sick, and then FDA will not let you use that tool, right? And they'll view themselves as being more careful and better equipped to use it, or the person licensing the tool will just want to be super careful because it's, it goes from X billion dollars of potential to zero, right? Basically the way, like particularly if you're looking at viral vectors and such, if you have a viral vector that is proven in a large population of people in a tissue type, then that is super beneficial for anybody that wants to deliver a gene or an edit or whatever to that tissue type. And before you have that, it's all hypothetical. And, if somebody dies, it evaporates. So that's kind of their concern, and it's sticky. There isn't like an easy way to navigate it.
All right. Thank you so much. Thanks for note-taking. I really appreciate it. All right, you guys, we're at the end of it. I know we're 5 minutes over time. I sincerely apologize for that. My German heart is crying. But this is a very tiny workshop of like workshops that are usually 2 days long. I guess the whole animation workshop that we're doing in May is going to be like 2.5 days long, with much longer breakouts and so forth. But we just want to give you like a taste of like, what kind of like new development, like what thinking about speeding up new developments in this field could look like, especially considering that we have a really strong kind of like new R&D and crypto expertise here as well. So thank you so much for joining. A few pointers for follow-ups. First and foremost, if you're interested in chatting more with people about this, join the Telegram group. It's across the different events. So it's not just this event, but it's other events in this series too. Many of you are already in there who were here from yesterday as well, and the longevity event. If you want to attend more workshops in this mini kind of like Path to Progress series, the next one is on nanotechnology tomorrow, which I think is still the most undervalued area. Then we have one on cryptography, security, and AI on Monday, and on space on Tuesday. So if you're interested in that, on the top of the collaboration doc is that link. Then there is the entire cosmos of LabWeek going on as we speak, with a pretty mind-blowing schedule. So this is the schedule for tomorrow. And then, of course, Funding the Commons, the big one, is Saturday and Sunday, which I think many of you would really enjoy. And this is kind of it for the next few days or so. If you want to stay in touch, we'll be sending out a follow-up email with a few informations about how to stay in touch with Foresight and Protocol Labs. But I just want to highlight that if you want to stay involved with Protocol Labs, here is the directory. So if you already cut yourself short, not follow the follow-up email, this is the directory where many projects kind of in this space exist, and it's a collaboration base for people in this space. With that being said, thank you so much, Protocol Labs, for making this possible. Thank you so much for so much brain power going into this. We can still be here for an hour if you want to hang out and have drinks. There'll be some served over there. Thank you so much for this really fantastic effort. Really appreciate it. And hopefully see many of you tomorrow. Thank you.
Thank you.